Alrighty, number 5. We want to find the area of the largest rectangle that can be inscribed in a semicircle of a radius of 4. So we have a semicircle here that is a radius of 4, which means that we're going to have an x value of -2 here and an x value of 2 here. Since we have a radius since we have a radius of 4, not a diameter of 4, that should give us -4 and 4. Sorry. Yep, -4 and 4. All right. Now, we want to find the area of the largest rectangle, so we want to maximize this using optimization. And since we want to find the area, this is going to tell me that this lovely thing, my rectangle, is going to be my primary equation. Now, you might be thinking that the rectangle is just going to be x times y because that's the area formula of a rectangle. Well, plot twist, no. And the reason why is because we have to look into account and take into account of my axes. Notice how this is a distance of x right here, and this is a distance of x right here, and this right here is just y. So my primary equation isn't going to be x times y, but instead it's going to be x plus x, aka 2x, and then we have our y. So my primary equation is 2x times y. So 2xy. Crazy. Now, our secondary equation is going to be my semicircle with a radius of 4. Now, if I were to think about this, in terms of a circle, this is going to be x squared plus y squared is equal to 16. We're only looking at the top part, so we're only taking the square root. So we're going to say y squared is equal to 16 minus x squared, and then y is equal to the square root of 16 minus x squared. So this right here is going to represent my secondary equation. All right, so now that I have my secondary equation right here, I'm going to use substitution to have one variable. So I have the area of 2x and then root 16 minus x squared. All right, this is going to be a mess because we're going to have to use product. And then with product, we're going to have to use chain. So this is going to be a lot of fun. I'm going to rewrite this so that it's 1/2, just to make my life a little bit easier. All right, whenever I'm taking the derivative of this, the 2 is just going to be a coefficient. I'm just going to take that out, and I'm only going to focus on x times 16 minus x squared times to the 1/2. All right, so I have first times the derivative of the second. Yep, already messy. Plus second times the derivative of the first, which, guess what? It's just going to be 1. Okay. So it might not be that bad. We'll see. Okay. Now we're going to set this equal to 0, right? So I'm technically just going to remove this 2 here because she's going to be non-existent anyways whenever we set this equal to 0. Now, we're going to try and make this pretty. How? I don't know. But I know that we are going to cancel out this 2 here and this 2 here. So she's gone. And then I have this negative x and x. So I'm going to have a negative x squared right here. And then I guess at this point, what we're gonna do is convert all of this back into a radical and see what happens. So I have 0 is equal to negative x squared, 16 minus x squared, plus 16 minus x squared. I'm going to move the 16 minus x, well, this thing right here to the left, so that this is positive, and this is now an equal to sign. So now I have that lovely thing right here. And then I'm just going to multiply this to the right. So then I'm going to have this lovely thing. Okay. So that just cancels out my radical. So now I'm left with a 16 minus x squared. I'm going to add the x squared. So I have 2x squared is equal to 16. X squared is equal to 8. Which means that x is going to be plus or minus 2 root 2. Now, obviously, because we're talking about the area, our x can't be negative. So x is going to be 2 root 2. Now, as a disclaimer, it is 12:55 a.m. on August 18th, okay? I am going to skip the sign chart part of this problem, and we're going to pretend that this is going to be a maximum, okay? So now what we're going to do is go ahead and find the area by going ahead and putting our x back into our secondary equation. So 16 minus, let's see, x squared is already 8 because that's what we already found here. So I'm just going to say 16 minus 8. So y is equal to root 8, aka 2 root 2. So both x and y are both 2 root 2 or root 8. So then the area is going to be 2 times root 8 times root 8. Root 8 times root 8 is just going to be 8. 8 times 2 is going to be 16. So our area of my largest rectangle that can be inscribed into this little semicircle is going to be 16 units squared. Crazy. I know. All right, in the next video, we are going to do number 6, which should be the last one in terms of our optimization lesson.